Every year at the big oncology meetings, the same argument breaks out. The trial is presented, the slide says statistically significant, the headline follows, and within hours, statisticians are pointing out the same problem they point out every year. Not that the study is fraudulent, not that the authors are dishonest. The problem is simpler. One number, the p-value, is being asked to mean something it cannot mean. This year was no exception. Some studies were too small to answer the question they were asking. Some showed promising signals that missed a statistical threshold. Some rested on a borderline p-value on a secondary endpoint. And some were called positive before anyone asked the harder question: positive for what, how large, and how reliable? So today, what statistically significant actually tells you and what it does not? The p-value may be the most over-interpreted number in medicine. The misreadings are so common that statisticians have published long lists of things a p-value does not mean. So let's ask the question we always ask: what was actually measured? A p-value answers a narrow question. Assume a statistical model. Assume the null hypothesis is true. In plain language, assume there is no real effect or no real difference in the way the model defines it. Then ask, how unusual would data like this, or more extreme than this, be under that assumption? That is the p-value. A small p-value means the data look unusual under the null model. That is all. It is not the probability that the null hypothesis is true. It is not the probability that the result happened by chance. It is not the probability that the treatment works. And p less than 0.05 is a convention. It is not a law of nature. Here is where the misunderstanding begins. A statistically significant result does not tell you the effect is large. If the sample size is big enough, even a tiny difference can become statistically significant. It does not tell you the effect matters to patients. A survival difference can be detectable and still be too small, too toxic, too expensive, or too uncertain to change practice. And it does not tell you the finding is true. Whether a published significant result is likely to be true depends on things the p-value does not contain. How many hypotheses were tested? How flexible the analysis was? How plausible the claim was before the study? How large the study was? And whether the result was selected because it crossed a threshold. That was the core warning in Ioannidis's famous paper on why many published research findings can be false. A p-value also cannot rescue a weak design. If a study is underpowered, stopped early, based on a secondary endpoint, or selected from many possible analyses, the p-value does not erase those problems. It only describes how surprising the observed data look under a specific statistical model. The danger is not the p-value itself. The danger is treating p less than 0.05 as a machine that turns uncertainty into truth. It does not. The human brain wants a verdict, positive or negative, worked or failed, significant or not significant. But evidence usually does not arrive as a verdict. It arrives as an estimate surrounded by uncertainty. That is why the better question is not, was it significant? The better questions are, how big was the effect? How precise was the estimate? What does the confidence interval allow? Was the endpoint clinically meaningful? Was this the main analysis or one of many possible analyses? And would this result matter to an actual patient sitting in front of you? So do not stop at the asterisk. Read the effect size. Read the confidence interval. Ask whether the result is clinically meaningful, biologically plausible, and consistent with the rest of the evidence. A growing group of statisticians has argued that we should stop using statistically significant as an on-off switch altogether. Not because statistics are useless, because evidence is graded. It is not binary. The p-value can be part of that evidence, but it should not be mistaken for the whole thing. None of this means p-values are worthless, and it does not mean every significant trial is wrong. A p-value does one specific job. It tells you how incompatible the observed data are with a specified statistical model, usually a model where there is no effect. That can be useful, and the reverse is also true. A non-significant result does not prove there is no effect. Sometimes the study was simply too small, too immature, or too disrupted to give a definitive answer. The mistake is reading statistically significant as true, large, important, or settled. A p-value is a smoke alarm, not a verdict. It tells you to look closer. It does not tell you the case is closed. So the next time you see statistically significant, do not hear proven. Hear the beginning of a question. How big? How certain? How meaningful? Compared with what? Follow the evidence. I'll see you next time under uncertainty.